Friends, actually, due to some issue, the videos has not been recorded. So I will tell you quickly what I had thought today. Uh, uh, yeah, I thought about how to calculate the mathematical equation. So here is some graphical representation is like this. How you will calculate this mathematical operation. So see, the zero is means we are moving the curve, we are moving this graph is moving from zero, and here slope is there. The slope, you know that is m slope is 2, 2, and there the value is 1. Okay, so y2 minus y1 divided by x2 minus x1, find the slope, you will get 2r of t. This slope is again means it's moving like this, and this 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 slope is getting nullified with the negative effect, so both will give you the step function. So that's why whatever the slope you are getting, you have to subtract it at what function it's happening, at one function, so t minus 1. So you will get the equations of the graph like this. Same thing in this. So what is the slope, this particular graph, what is the slope? You are getting 8 divided by 0 minus of minus 2, so you are getting the slope, that is 4. So this 4 slope is moving like this. You are getting the step functions at 0 point, so you have to nullify this slope effect by adding with the negative slope. Okay, now the graph will move like this, and again here the negative slope is coming. Okay, so find the slope of this y2 minus y divided by x2 minus x1, so you will get minus 2 r of t minus 4. And again this slope is moving like this, but the affected, it's moving in a zero direction, so you are adding, this is the negative slope, so you are adding the positive slope, so both will give you the balanced result in a zero axis. So same way I'd solve this step function. So this step functions, how it's solved? So 0, from 0 the step function is moving to a minus 2. Minus 2 at what point? U of t plus 1. U of t plus 1, minus 1 is there, so u of t plus 1. Then minus 2 to 5. So minus 2 to 5, how many increment is there? So it will reach to minus 5, 5. So minus 2 plus x is equals to 5, so x value will be 7. So 7 increment is there, so 7 u of t. Again at t is equals to 1, the decrement of 3.5, that's what, then only it will reach to 1.5. So 5 minus 3.5, you will give you 1.5, so we'll get the result like this. So in this way all the equations has been solved here. Okay, so here two operations are happening. This blue color graph is there, so two operation is happening, it's moving like this is your curve, this is particularly two operations. So it will first make the step function, then the step function will get nullified. So that's why here two operation is happening at rt point. So negative slope will come, negative slope is coming, then step function is decreasing by how much? By 8. So the same way you can find the equations of this particular graph equations, you can find it. Okay, so this is the process to find the graph equations. Okay, yeah. So this particular 8 questions I discussed. After that I had moved to a differentiation operation. So differentiation is nothing, you need to find the equations. First find the equation, then do the differentiation. And I told you the differentiation of a r of t is u of t, and the differentiation of a u of t is delta of t. So here if you will find the equation of this, then if you will differentiate it, you will get particular equation 2u of t minus 2u of t minus 1. So 2u of t minus 2u of t minus 1. So I discussed today these things. Okay, now you have a triangular pulse like this. So here again you need to find the differentiation, find the signal of this particular graph, then differentiate it, you will get this kind of a signal. 4 u of t minus 10 u of t minus 2 plus 6 u of t minus 4, you will get this particular signal. And here the signal is 2 u of t minus 2 u of t minus 4. If you will differentiate it, you will get the impulse signal. So this denotes the area, not magnitude. So 2, this will be minus 2. And for periodic signal, finding for the periodic signal, you need to take one particular point, one particular period. So in the same way, I have taken one particular period, I find the equations of this. So for this I am getting a one square pulse. So if it is for one triangle square pulse, so another triangle also the square pulse will come, so it will give you the periodic results. And here I find the power of that signal. Power is nothing but the RMS square. So what is the RMS square of this signal? Find this, you will get 16. These things I already discussed in the previous lectures. uh, Due to some issues, the whole video is not getting updated, so that's why I'm giving the short view, so that you guys will be updated from that point of view. Okay, videos. So this is the differentiation. Then after the differentiation, and always remember, derivative of periodic signal will always be periodic. Okay, and these things, whenever you will get the positive slope, you will get the positive area. In a derivative, you will get the negative slope, you will get the negative area. This point is very much important. And about the integration, same thing. Find the equation. So here I find the equation, and the integration of a u of t is r of t. Okay, I took this signal and I'd just simply integrate this signal. So the equation is given, integrate this signal. Okay, then you have this particular question. So I will discuss these questions tomorrow. So this was the today's discussion of the class. I hope you guys enjoyed it, and you like this video. Oh, thank you.